Wormholes are imagined passageways through time and space. When the wormhole theory was developed, is there a wormhole in our solar system? According to the wormhole hypothesis, enormous distances throughout the cosmos could be shortened by a fictitious transit through space-time. General relativity makes wormholes a possibility. Be cautious though, as wormholes pose risks such as abrupt collapse, intense radiation, and potentially hazardous contact with unusual materials. Though they weren't initially dubbed wormholes, the theory of them dates back to 1916. Austrian physicist Ludwig Flamm discovered a different solution to Albert Einstein's general relativity equations while examining one provided by another physicist. He talked about a white hole, which is a black hole's hypothetical time reversal variant. There might be a space-time conduit that connects the entrances to both black and white holes. The probability theory states that a wormhole may appear adjacent to our planet in the solar system, as well as 200,000 light-years away from us, but it could also exist concurrently on both sides of the vortex. General relativity was utilized by Einstein and scientist Nathan Rosen in 1935 to develop the concept and suggest the presence of bridges between space-time. These bridges link two distinct locations in space-time, hence posing the possibility of a shorter route that would shorten travel times and distance. The wormholes or Einstein-Rosen bridges are the names given to the shortcuts. Stephen Hsu, a professor of theoretical physics at the University of Oregon, told our sister site, Live Science, that the entire situation is now quite hypothetical. Nobody believes that a wormhole will be discovered anytime soon. A paper in the Journal of High Energy Physics 2020 states that wormholes have two mouths connected by a throat. Most likely the mouth would be spheroidal. The throat could take a longer course than a more direct route would require, or it could be a straight stretch. Although wormholes are predicted mathematically by Einstein's theory of general relativity, none have been seen thus far. It is possible to detect a negative mass wormhole by observing how its gravitational field affects nearby light. The presence of wormholes with black holes at each end is permitted by some general relativity solutions. A wormhole cannot be produced by a naturally occurring black hole, which is the result of the death of a star. There are many wormhole travel stories in science fiction. Although we haven't yet seen one, the reality of such travel is more problematic in general. The size is the first issue. It is expected that primordial wormholes exist at teeny scales of 10 or 30 centimeters. However, it's feasible that some have grown to enormous sizes as the cosmos has expanded. Stability is a different issue. The projected Einstein-Rosen wormholes would be unstable and worthless for travel. It's unclear whether such matter exists in the universe, according to Xu. You would need some very exotic type of matter in order to stabilize a wormhole. Can one travel through time? The best time travel devices are wormholes. What occurs when black holes enter wormholes? A wormhole containing exotic material, however, was discovered to be able to remain open and unchanged for long periods of time in more recent studies. Exotic matter had a high negative pressure and a negative energy density, which should not be mistaken with dark matter or antimatter. Only in the behavior of specific vacuum states has such matter been observed according to quantum field theory. According to Live Science, a wormhole could hypothetically be utilized to convey data or travelers through space if it included enough exotic material, whether naturally occurring or purposefully created. Unfortunately, trips by humans through the space tunnels might be difficult, but we think so. It's our suggestions. According to physicist Kip Thorne, one of the world's foremost experts on relativity, black holes and wormholes, the jury is not in, so we just don't know. But there are very good reasons to believe that the rules of physics prohibit human transit through wormholes. But it's just nowadays science. Maybe in some few thousands of years or even hundreds of years, we will be able to travel through space and time. Who knows when it could happen? That's bad and depressing, but that's the way things are going, just like we think now. What manages wormholes? Wormholes might link not only to distant areas of the same universe, but possibly to other universes. Similar to this, some scientists have hypothesized that time travel would be possible if one mouth of a wormhole were to be moved in a particular way. According to astrophysicist Eric Davis, traversable wormholes allow travel into either the past or the future. It won't be simple though. Creating a time machine out of a wormhole would require Herculean effort. It will be difficult to pull off a wormhole, but it can be possible. However, according to British cosmologist Stephen Hawking, such application is not feasible. According to NASA's Eric Christian, a wormhole is not really a way of going back in time. It's a shortcut so that something that was far away is much closer. It's possible that the addition of regular matter might be enough to destabilize a wormhole, even though adding exotic matter could stabilize it to the point that human passengers could pass through it without danger. Even if wormholes could be detected, current technology cannot stabilize or enlarge them. However, in the hope that the technology will one day be able to use them, scientists are still researching the idea as a means of space travel. It would require some extremely cutting-edge technologies, so added. Humans won't be performing this anytime soon. But in the nearest future, who knows? Maybe everything will change.